Turn your flipbook upside down so we're looking at the back page. And the back page, the bottom right hand corner, I wanted to go over something regarding slope that I have seen in the past that many students will struggle with. And so let's talk about this thing about horizontal line slopes and vertical line slopes. So our example of that is we're learning about slopes right now in the current unit, and we're learning something here. If I draw a coordinate grid real quick here, and I'll put a line segment on here. So let's go ahead and change this color. And we talked about, oops, that's not right. Let's try that again. And this is the wrong color. Let's try this. All right. So here is a line segment on a coordinate grid, and we talk about how to figure out the slope of this line is rise over run. How fast is it going up? And that's the numerator. And then how fast is it traveling left to right? That's the denominator, and that would give us the slope. Probably talked about already in class what's a positive slope versus if I change this and make it a negative slope. But our issue here is dealing with a line or a line segment that is either exactly vertical, meaning it's flat. We could also say it's parallel to the x-axis, or dealing with a line segment that is exactly straight up and down, or vertical. Sorry, I'm not sure if I said vertical on the other one. It's horizontal, means that it's parallel to the x-axis. Vertical means it's parallel to the y-axis. And most students can remember that one of these slopes is 0 and one of these slopes is undefined or infinite. The question is how to remember which one is which. So this section is just to give you a visual way of hopefully remembering which one is which. So you can see I filled in here. A horizontal line has a slope equal to 0. A vertical line has a slope that is either considered, we either call it undefined, or we call it an infinite slope. If you want to go ahead and label this, you remember this is the sign for infinity. So we're going to put the word infinite. It means we really can't measure it. If it's vertical, we can't measure the slope because it's infinite. So here's how I remember this, and hopefully this will help you remember it. Let's take a look at a horizontal line. So I'm going to draw that right now. Oh, let's make it actually look pretty. So here's a horizontal line. And let's just say that I'm going to put myself standing on this horizontal line. Now I'm not going to do a bunch of real artsy work here. Let's just put a face. I'm happy today. And here am I, standing on a horizontal line. Now think about this. If I'm on the side of a snowy slope or an icy slope, if the slope is positive or negative, I'm going to start sliding down. I don't know if you've ever been on a sled or ice skating on any kind of slippery surface. If you try to stand still, if it's slippery, you're going to start sliding down it. So if we've got a positive or a negative slope, you're going to start sliding. But if you have a horizontal slope, or a slope that's totally flat, I can stand here all day, just like I'm standing in class every day for you guys, and I'm not going anywhere because the ground I'm standing on is horizontal. And that means that I have a slope of 0. So the way I think of this is there's no slope here because I'm not going anywhere. So I'll usually write this as something like this. Let's see, I'll find a different color. Okay, I am not moving. I'm not moving if I'm standing on a horizontal line or a flat surface. And that means there is no slope. There is no slope. So slope, and that got messy. Let me fix that. I don't know what happened there with my craziness. Okay, that means our slope is equal to 0. So when you think of a horizontal line and you're trying to think to yourself, okay, is that a slope of 0 or is that infinite? I don't remember. Just think of yourself standing on that particular line segment. If you're not going anywhere, if you're not moving, then there is no slope. Now let's talk about a vertical line. So now I'm going to draw a vertical line here. Alright, and let's go ahead and draw me. Well, wait, we got a problem. There's nothing for me to stand on. If that's what the floor of this room looks like, and I'm trying to stand on it, I've got nowhere to stand. So let's go ahead and draw me, and I'm not going to be as happy over here unless you like to fall. So I'll put a frowny face here. Okay, let's draw some lines to show you that I'm actually falling. Okay, so if this is what the floor looked like in this room and I tried to stand on it, I would just fall forever. I would just fall and fall and fall. I'd never hit bottom as long as there's not another slope or a horizontal line somewhere on the bottom. I just keep on falling forever. So the way I write this is I am falling forever. I'm falling forever. And so that tells me that the slope is infinite. Falling forever, forever means infinite. So that helps me remember that the slope of a vertical line is undefined or infinite. So there's our two examples. Horizontal line, I'm not going anywhere. That means there is no slope, so slope is 0. Vertical line, a vertical line, I fall forever because I never actually hit bottom. The slope must be infinite. And one more thing to note about horizontal and vertical lines, and you can write this maybe toward the bottom of your diagram here. Horizontal and vertical lines are always, and I'll underline that, are always perpendicular. So we learn in another section about perpendicular lines and what we can say about the slopes. And make sure I got that spelled right. Perpendicular. Yeah. We learned about the slopes or opposite reciprocals when two lines are perpendicular. Well, this is one of those exception cases or interesting cases where you just need to know this. If you have a horizontal line and a vertical line and they cross each other, they will always be perpendicular to each other.